Welcome to Science News Review for July 14, 2026. Today, we look at a new theory on the makeup of dark matter, the search for alien Dyson spheres, and the discovery of superpuff planets with the density of shaving foam. For years, the standard view was that dark matter consisted of a single type of particle, but a new study suggests the reality is more layered. Researchers propose that dark matter actually consists of at least two different kinds of particles that slowly separate over cosmic time. In this model, the particles behave differently based on their mass. The heavier particles gradually sink toward the centers of galaxies. The lighter ones drift toward the outer edges. This separation could solve several long-standing puzzles at once. It explains why some dwarf galaxies appear unusually diffuse, while other regions show the incredibly dense clumps of dark matter that bend light through gravitational lensing. While dark matter shapes the invisible structure of the universe, other astronomers are refining how we look for signs of advanced technology. Specifically, they're hunting for Dyson spheres. These are hypothetical megastructures a civilization might build to harvest the energy of their host stars. Rather than searching everywhere, new research suggests focusing on red dwarfs and white dwarfs. These stars might be the most efficient targets for a civilization building massive energy, harvesting swarms. The search is also shifting away from visible light and toward infrared signatures. A Dyson sphere would likely glow in the infrared spectrum and show unusual flickering patterns as it orbits. This is a distinct signature, and it's different from the dusty clouds typical of natural stars. By narrowing the search to these specific stellar types, astronomers can move from general speculation to targeted observations of the galaxy's coldest energy candidates. From theoretical structures to actual planets, some worlds are turning out to be far stranger than expected. Astronomers have discovered a pair of extreme worlds orbiting the star TOI 791, located about 1,113 light-years from Earth. Using data from the TESS Space Telescope and the ASTEP telescope in Antarctica, researchers identified two Jupiter-sized planets that belong to a rare group known as superpuffs. While they are roughly the size of Jupiter, they possess less than 6% of its mass. This gives them incredibly low densities, comparable to the consistency of cotton candy or shaving foam. By observing the way these planets gravitationally tug on one another, scientists calculated their masses at approximately 9.5 and 18.6 times that of Earth. There are two main theories for why these planets are so puffy. One possibility is that they formed far from their host star and migrated inward. There, intense heat caused their atmospheres to expand. Another possibility is that they are simply very young planets, still in a stage of cooling and contraction. Some scientists suggested that large ring systems might make a planet appear larger than it actually is, but astrophysicist Anthony Pyro of the Carnegie Observatories suggests that it is unlikely for these specific worlds. The next step is to use the James Webb Space Telescope to study the chemical composition of these atmospheres. That data should reveal whether these worlds were expanded by heat or if they are just in a transient stage of their lives.